Good day, everyone, and welcome to the third lesson of your general mathematics class, which is functions as mathematical models. So this is the fun part, no? Because in here, you'll be able to relate functions to real-life situations. Because many processes studied in the physical and social sciences involve understanding how one quantity is related to another quantity. Determining the function that describes the dependence of one quantity on another is what we call the mathematical modeling. Modeling real-world problems, especially those that require optimization, is one of the important applications of the study of functions. So I hope that at the end of this lecture, you will be able to appreciate the essence or the importance of functions. So before we proceed with examples, real-life examples in which we can associate functions, let us define function machine first. Function can be illustrated as a machine where there is the input and the output. When you put an object into a machine, you expect the product as output after the process being done by the machine. So in this figure, no? Basically, this definition of function machine is just the definition also of our function as itself, no? Diba? I have discussed that in function, we can call a relation a function if and only if one input can only generate one output, no? Not two or more. So in here, in our machine, in function machine, it says that, let's say we have input, we put something on the in the machine, and then with that, with whatever rule that the machine has is, we'll have an output, only one output. We can't have two or more outputs. Say for example, we put orange in the juicer, no? Orange fruit in a juicer. So we would expect that the outcome is an orange juice, no? We can't have an outcome which is a grapes or orange and grapes juice because you only put orange in that machine, which is what the machine I'm talking about is the juicer. Okay. So how do we make a function model? So the function machine is represented by a function rule. For example, if a function machine always adds 3 to whatever you put in it, you can derive a function rule of f of x equal to x plus 3, where x is what you input in the function machine. So for example, now this one, so the machine here has a function rule which is it always adds 3 to whatever you put in it. So that is why we'll have a function rule which is f of x equal to x plus 3, in which x is the input and f of x is the output. Okay, so that is how we make our representations, no, for the function machine. Okay, so say for example, we have a person which is earning 500 pesos per day for doing a certain job. Which of the following expresses the total salary as a function of the number of n of days that the person works? So in generating a function rule, or in trying when you try to model a particular situation, you need to identify what is the input or the independent variable first, and also the dependent variable or the output. So in this case, what do you think is the input? Yes, it is the number of days that the person works. Alright, and the output, of course, is the total salary that the person will be getting. So you already have your input and your output. The next thing that you need to do is to observe the situation. What is the rule here? The rule here is that a person is earning 500 pesos per day. So it's 500 pesos per day. So that is why your representation now will be S of n equal to 500 n, or 500 times n, in which n is your number of days that the person worked, and S of n is the total salary, no, that the person will be getting. So it's that simple. So what do you think is the domain? Okay, we have here, domain is from 0 to positive infinity. Why? Because we cannot have negative n or negative number of days, right? We count from 0, 1, 2, 3, like that. So our domain is from 0 to positive infinity. Okay, so this is just an easy example. So let's try to solve how much the person will be earning if he or she will work for 10 days or for 20 days and for 17 days. So to solve that, it's actually very easy. You just have to evaluate the function using these values. So first, let's try to solve for 10 days. You just have to substitute n with 10. So we have S of 10 equal to 500 times 10. So that is why the person will be getting 500 pesos if the person will work for 10 days. How about 20 days? You just have to substitute 20 to n, and then you'll find 10,000 pesos. You'll be able to solve for 10,000 pesos. And then for 17 days, you have 8,500. So that's how we model real-life situations, no, using function. So let's have another example. Judy is earning 300 pesos per day for cleaning the house of Mrs. Perez and additional 25 pesos for an hour of taking care of Mrs. Perez's child. Express the total salary of Judy, including the time H spent for taking care of the child. Okay. So what do you think is the domain or the input or the independent variable here? It is the time Judy spent taking care of the child. And the output here is the total salary S. Next thing to do is to observe the situation and generate a function rule. What do you think is the what do you think will be the function rule? See, you have 300 pesos per day. So here we have 300 plus, if Judy will take care of Mrs. Perez's child, she will get 25 pesos per hour. So that's why we have S of H equal to 300 plus 25H, where H is the number of hours Judy spent taking care of the child, and 300 here is her pay for cleaning the house. So this is the model of this situation. Okay, so what do you think is the domain of this function? So H can only take 0, non-negative, right? 0 to positive infinity. Okay, the same, no? Because we don't have negative number of hours. So let's try to solve. How much will Judy earn if she'll take care of Mrs. Perez's child for 12 hours? Simple. You just have to substitute 12 for H, no? So we have S of 12 is equal to 300 plus 25 times 12. And if you solve that accordingly using JAMDAS, you'll get 600 pesos. So Judy will be getting 600 pesos if she will take care of Mrs. Perez's child for 12 hours. So ayan, easy lang, no? So it's simple. Let's try another example. This one. Emma and Brandon drive away from a campground. Emma went north and Brandon went east. Emma's speed is 40 kilometers per hour and Brandon's speed is 75 kilometers per hour. Express the distance between the cars as a function of time. Ayan. So the situation is like this. So they came from the same campsite or campground. And then, mag-separate na sila, no? Si Emma papuntang north, si Brandon papuntang east naman. Okay. So we are looking actually for the distance between the two cars, no? Emma's car and Brandon's car. So this red line here represents the distance, no, between Emma and Brandon. Familiar ba yung figure? Yes, no? You were able to make a right angle triangle, no? Right triangle. So, when we say right triangle, anong nasa isip natin? Pythagorean theorem. So, I believe, I hope that everyone is familiar with Pythagorean theorem. So, let's say E is the distance covered by Emma and B is the distance covered by Brandon from the camp. D will be the distance between Emma and Brandon. So how do we solve for D? Because we are looking for D here. With this, we'll have D squared equal to E squared plus B squared using the Pythagorean theorem. Okay? So how can we relate it with our situation? Okay, so we're looking for D, so we need to square root both sides. So we'll have square root of the sum of the squares of E and B is equal to D, which is the distance of Emma and Brandon. So how can we relate it with the situation? We know that Emma's speed is 40 kph. We also know that Brandon's speed is 75 kph. So that's why we need to substitute only, no, 40 t. What is t? T is the time, no, that Emma and Brandon drove, no. So in here, t is our input or our independent variable, the number of hours they're driving. And d of t will be the distance between Emma's car and Brandon's car. So if you are to simplify this one, so the square of 40t is 1600t squared. The square of 75t is 5625t squared. So combine like terms, you will get square root of 7,225 t squared. So, is 7225 a perfect square? Yes, it is a perfect square, and its square root is 85. So you'll have d of t equal to 85t, where t is the number of hours Emma and Brandon's driving, and the d of t is the distance between Emma's car and Brandon's car. So you will use this representation, no, or function. So if you're asked, let's say, what's the distance between Emma's car and Brandon's car after 5 hours, you'll just have to replace t with 5. So easy, diba? If you have this, you can solve it directly. So that's the essence of functions as mathematical models. Okay, let's try. The domain also here is from 0 to positive infinity. Why? Because we don't have negative na distance. Diba? Alaman niyo lahat. Sige. So, meron na tayong function rule or representation ng situation. Let's try to solve the distance between Emma's car and Brandon's car after 3 hours of driving. Okay, in solving, we just have we just have to substitute t with 3. So you have d of 3 equal to 255 kilometers. So this will be the distance between Emma's and Brandon's car after 3 hours. So ganyan lang siya kadali. Ang challenging na part is yung pag-generate ng function rule or ng model talaga. So pag-solve na is substitution na lang. Okay? So, gets. Okay. So, meron tayong other na type ng functions, which is the piecewise functions. Okay. Ano ba itong piecewise functions? A piecewise function is a function in which more than one formula is used to define the output. More than one formula. Each formula has its own domain, and the domain of the function is the union of all these domains. We notate this idea like this. Okay. Say may f of x. F of x equal to, let's say, formula 1 if x is in domain 1, formula 2 if x is in domain 2, formula 3 if x is in domain 3. Okay, para mas maintindihan siya, let's have an example. During GCQ, the proposed tricycle fare in Lucena City is 15 pesos for the first 4 kilometers of travel and 2 pesos for each additional kilometer over the proposed fare. So, ayan. So, again, para makapag-represent tayo ng function, para maka-generate tayo ng function rule or model for this situation, we need to identify the domain and the range first. So, ang domain dito, or the independent variable, is the kilometer over the, is the distance, no, that a passenger traveled, no, or that tricycle traveled. So, yan yung ating independent variable or our domain. So our range here is the tricycle fare. Okay? So ayan, na-identify na. Next is you observe yung situation. Sabi dito, we have 15 pesos for the first 4 kilometers and 2 pesos raw for each additional kilometer over the proposed fare. So, mayroong dalawang condition, no? If yung destination mo is 4 kilometer or less, you'll only pay 15 pesos. So, kahit 1 kilometer ka lang or kahit 1 kilometer lang yung destination mo, the same ang babayaran mo with the person na magka-travel ng 4 kilometers. So, ayan yung ibig sabihin ng first na statement. Tapos, sabi dito is 2 pesos for each additional kilometer over the proposed fare. So, if lagpas ka ng 4 kilometers, say 5, 6, etc. So, mag-a-add ka lang ng 2 pesos per kilometer na lumagpas. So, for the first one, so our piecewise function here is f of x equal to 15 if x is less than or equal to 4, and 15 plus 2 times the difference of x minus 4 if x is greater than 4. Itong nasa taas na condition or formula is if first 4 kilometer travel, yan yung sinabi ko kanina, di ba? So, 1, 2, 3, 4, 15 pesos talaga yung babayaran. Itong pang second naman, yx minus 4. Yx minus 4. X minus 4 because ang babayaran mo lang na additional na 2 pesos is yung mga lumagpas na kilometers after ng 4 kilometers. So, say for example, 6 kilometers. So, hindi 6 times, hindi si 6 yung i-multiply mo kang 2 para sa additional na fare. Ang i-multiply mo lang is yung lumagpas na distance, which is 2 kilometers. So, yun ang i-multiply mo sa 2 pesos, which is the rate for each kilometer. That's why we have x minus 4 here. So, that's our piecewise function for this situation. And the domain, of course, is from 0 to positive infinity because our input or domain is the distance na na-cover. And wala tayong negative na distance. Okay. So we have this piecewise function. So let's try to solve how much would Joshi pay if she'll be traveling 10 kilometers. Okay. So sa piecewise function, dapat tingnan mo kung saan ba nabebelong si 10 kilometers. So si 10 kilometers, saan siya? Sa first or sa second? Second, right? Because 10 is greater than 4. So that's why we will use the second. So we have f of x equal to 15 plus twice the difference of x and 4. So substitute tayo ng 10. You have 15 plus 2 times 10 minus 4. So solve accordingly and you will get 27 pesos as a fare kapag 10 kilometers yung na-travel ng passenger or ni Joshi. Okay? So, ganyan lang. Another example. A user is charged 400 pesos monthly for a Sun and Text mobile plan, which include 500 free text messages. Messages in excess of 500 is charged 1 pesos or 1 peso each. Represent a monthly cost for the mobile plan using S of t, where t is the number of messages sent in a month. Ayan. Klaro naman kung ano yung domain, no? Kung ano yung ating independent variable. Our independent variable is the number of messages you sent in a month. And our output or the range is what? The monthly cost for the mobile plan. So looking at the situation, mayroon dalawang condition, no? Or dalawang situation. So first is if hindi ka lang mag-pass sa 500 free text messages na allotted for 400 pesos na plan. And the second is if lumagpas ka sa 500 pesos na 500 messages na plan. So the piecewise function will be 400 if t is less than or equal to 500, meaning 500 text messages or less, and 400 plus t minus 500 where t is greater than 500, which means more than 500 text messages yung na gamit mo sa in a month. Okay. So ang domain pa rin dito is from 0 to positive infinity because you can send a negative number of text messages, no? Okay. So let's try to solve if how much would it cost for Riley if she sent 1,000 messages in a month. So again, ang gagawin lang natin is mag-substitute. So we have before mag-substitute, tingnan muna natin kung saan nabibelong si 1,000 messages. Of course, a second, no, because t, which is 1,000, is greater than 500. So that's why we'll use this second formula or equation, which is S of t equal to 400 plus t minus 500. Next thing to do is to substitute 1,000. Okay, so you'll have S of 1,000 equal to 400 plus 1,000 minus 500. And if you solve it accordingly, you get 900 pesos. So that is now your cost, or what will you pay if you will send 1,000 messages. No? If lumagpas ka sa 500 messages ng plan. Okay? So, ganyan lang ang ating representation of functions. We have, first, we really need to get the domain and the range first para we know which one is input and the output. After that, observe no ang situation, if applicable ba si piecewise or not. And then generate your function rule. At yan na magiging model, function model ng real life situation. So I think that's it. Thank you for listening and God bless.